Hello, my name is Giselle Alvarado and I attend Adosa College. Today I will be solving problem 1633 from the Engineering Mechanics Dynamics book. Before I do this, I will give a background knowledge a little bit. So angular motion in these kinds of problems, in the rotation about a fixed axis problems, does not exist. It only exists in lines or bodies. Angular position is measured from a fixed reference line r. The angular displacement is a differential of d theta. So we just take the derivative of theta and we find it. And then angular velocity is the time rate of change in an angular position. So then we skip to this. The driving belt is twisted so that pulley B rotates in the opposite direction to that of drive wheel A. If the angular displacement of A equals 5t cubed plus 10t squared radians, where t is in seconds, determine the angular velocity and angular acceleration of B when t equals 3 seconds. So the picture shows that when B rotates counterclockwise, this goes clockwise, A goes clockwise. The radius for A is 200 millimeters and the radius for B is 125. The first thing I'm going to do is write knowns and unknown. So theta A equals 5t cubed plus 10t squared. RA equals 200 millimeters. Theta B is an unknown. The radius for B equals 125 millimeters. And then they ask us to look for velocity. And these are both unknown. And for acceleration. And we also don't know these. They only ask for acceleration and velocity of B, but we have to find them for A as well too in order to do that. So the first thing we're going to do is write the equation again for displacement. As I said before, velocity equals the derivative of theta A. So we just find the derivative, which is 15t squared plus 20t. And then alpha A is going to be the second derivative, which equals 30t plus 20. The problem here states, right here they ask for t equals 3 seconds. So they ask velocity. We then plug 3 into the velocity equation, which is 15 times 3 squared plus 20 times 3 equals 195 radians per second. This here is the velocity for pulley A. We then, from here, this step, we then use the speed ratio. The speed ratio states that omega A over omega B equals radius of B over the radius of A. So the only unknown in this equation is omega B, and that's what we can solve for that. So this is 195 over omega B, and then equals 125 over 200. We solve for this and it gives us omega B equals 312 radians per second. The next step is to find alpha B. So in order to do that, we once again have to use the speed ratio, except this time I'm just going to flip it. So omega B over omega A equals 200 over 125. And so then we, instead of using this 195 for omega A, we're going to use the equation, this here. That way we can find the derivative. So 200 over 125 times 15t squared plus 20t is we do the derivative. That way we can find alpha. This is omega B, and we have to find alpha B. So just a derivative. So this stays the same. And then 30t plus 20 is alpha B. And this is the equation for acceleration. So we use the same equation. Let me write it again here so we can see it. 200 over 125 times 30t plus 20. And we just, since the question asked for 3 seconds, we put it in here. So 200 over 125 times 30 times 3 plus 20 is going to equal 176 radians per second squared. So this here is the acceleration for B. So that's alpha B. This means that when this pulley here, when A is rotating at 195 radians per second, this is going 195, the pulley B here will be going 312 radians per second. So this rotates 195 and it makes this rotate 312 radians per second. And when t equals 3, the acceleration of the small pulley will be 176 radians per second from here. Okay, thank you for watching.